Hello everyone, welcome to the ITLS Academy. Today we are going to start our new topic, that is particular media required for particular microorganism. Okay, see, every microorganism required a special type of media. This type of media is called what? Selective media. First of all, do you know what is this media word mean? Media is a food of the microorganism. They are what? They are the food of the microorganism. Now, selective media means that they required a microorganism required a selective media for their growth. Suppose there are two type of media, A and B, and A media is required for the growth of C and B media is required for the growth of the D. When we grow on a A media and what we want to require to grow D type of microorganism, then it will be not possible. So this is the concept of the selective media. C is C for C, A is what? A is selective media. And if we want to grow B type of microorganism on the A type of the media, then it is not possible. That's why we are called that particular media is required by a particular type of microorganism for their growth, especially for their growth. Now next is what? Coliform. Coliform is what? Coliform is a type of bacteria. This is what? This is a type of the bacteria which is mainly grow on media that is you call violet red bile agar. Okay. Coliform grow on a selective media, and this selective media is what? Is violet red bile agar. Okay. Now, what is in every lab, it is not possible that violet red bile agar are present. Okay. So, if it's not present in our laboratory, then what should we do? Then we see their composition. Then we see their composition. Now see, this violet red bile agar are made up of different type of chemicals. These chemicals are what? These are yeast extract, peptone, sodium chloride, bile salt, lactose. Okay. If someone asks you that this violet red agar are made up of which type of chemical, then you can easily say that it is made up of yeast extract, peptone, sodium chloride, bile salt, lactose. Okay. Now, amount of these required are what? In which amount of these all chemicals are required? This is required that amount. Now, this amount is for 1 liter of distilled water. So, for 1 ml, for 1 liter of distilled water, we required yeast extract 3 gram, peptone required 7 gram, sodium chloride required 5 gram, bile salt required 1.5 gram, and lactose required 10 gram. Suppose if we want to decrease the volume of the distilled water, then this amount will also be decreases. It is clear? Now, what should we do? Again, we divide this water into two parts, 500 ml and 500 ml. Then after that, we add all these ingredients into the 500 ml of distilled water. And after that, what we have to do, we maintain the pH. Here the pH will be 7.4 plus minus 2. And how we maintain this pH, the video is already uploaded in our account. You can visit it and see it. Now, when the pH is maintained, what should we do? We add this 500 ml of distilled water into it and make up the volume 1 liter or 1000 ml. After that, what should we do? We do a autoclave. How we do the autoclave, it is already discussed and the video is already uploaded in our account. You can go through this and see how we autoclave the media. We required rose bangle 5% solution W by W dichloron, that is called 2,6 dichlorophore nitroaline solution, and this solution dissolve into a 0.2% of weight by volume in ethanol, chlorophenicol, distilled water, and this is what? This is your agar. Okay, the amount required, glucose required 10 gram, bacteriological peptone required 5 gram, potassium phosphate required 1 gram, magnesium sulfate, heptahydrate required 0.5 gram, rose bengal required 0.5 ml, dichloron required 1 ml, chlorophenicol required 0.1 gram, and agar is required 15 gram. Again, what should we do? We divide the distilled water into two parts. One is again your 500, and then we add this ingredient or this chemical into a 500 ml of distilled water and maintain its pH. And the pH will be again, it is same 7.4 plus minus 2. When the pH is maintained, then what should we do? We add remaining 500 ml of distilled water and again we do an autoclave. Clear? Next, E. coli. E. coli should be grown into LB agar, that is your L'Oreal Bartani agar. So this agar should also be, the composition is here and we require this composition for 1 liter of distilled water. Okay, so casein peptone is required 10 gram, yeast extract required 5 gram, sodium chloride required 10 gram, agar required 15 gram. And again, what should we do? We dissolve all these ingredients into a 500 ml of distilled water and maintain its pH. pH is what? pH is maintained 7.4 plus minus 2. And again, what should we do? We add remaining 500 ml of distilled water. This is your LB agar, L'Oreal Bartani agar. Here you can see that it is very clear that when we change the types of microorganism, along with the selective medium will also changes. Now next is your Enterobacteriaceae. Enterobacteriaceae required the media that is called VRBGA. That is your violet red bile glucose agar. See, suppose if in your lab this media is already present, like VRBGA media present, then you don't have required this composition. But suppose if in your laboratory VRBG agar is not there, but you want to grow a Enterobacteriaceae in your lab, then at that time you are required this composition. Okay, so VRBGA is made up of what? Yeast extract, peptone, sodium chloride, bile salt, lactose. And this composition is for what? For 1000 ml of distilled water. Now we require yeast extract 3 gram, Peptone is required 7 grams. Sodium chloride is required 5 grams. Bile salt is required 1.5 gram and lactose is required 10 grams. Now, same process will be followed. We divide the distilled water into two parts, 500 ml, 500 ml. Then in the first 500 ml, we added all these ingredients into it. And again, we maintain the pH 7.4 plus minus 2. Okay. Now, after maintaining the pH 7.4 plus minus 2, we add remaining this 500 ml distilled water. See, in your mind, one question arises that why we maintain this pH before adding all the water. See, suppose when you added all the distilled water into it, and after you are going to maintain the pH, then in that case, maybe some variation will occur. That's why we are added the distilled water after maintaining the pH. And one more thing, we are not dissolving all these ingredients directly into a 1000 ml of distilled water. We divide this distilled water into two parts. This is because so that these all ingredients will dissolve easily. That's why we are not adding all these ingredients directly into a 1000 ml of distilled water. Now the next is your Pseudomonas aeruginosa. Pseudomonas aeruginosa required LB agar. That is your Laurier Bartani agar. And the composition is what? Casein, peptone, yeast extract, sodium chloride, agar, and distilled water. Same, we divide it into a 500 ml distilled water. And after maintaining the pH 7.4 plus minus 2, after that we added this remaining distilled water. See, maintaining of the pH is very important. This thing is we already discussed that why we maintain this pH, so that it will solidify easily. Okay, if you are not going to maintain this pH, then it will not be solidified. That's why in every time when you are preparing your media, you have to maintain its pH. After that, maintaining the pH and adding this distilled water, you have to autoclave it. Without autoclave, you are not using the media. Because if you are using the media without autoclave, then it will disturb your result. Vibrio cholera. Vibrio cholera required the media thiosulfate, citrate, salt, sucrose, agar. And the composition of this thiosulfate, citrate, bile, salt, sucrose, agar are what? Protease peptone, yeast extract, sodium thiosulfate, sodium citrate, bile, sucrose, sodium chloride, ferric citrate, bromothymol blue and thymol blue and agar. Now the amount of these ingredients required per liter. Protease peptone required 10 gram, yeast extract 5, sodium thiosulfate 10, sodium citrate 10, bile 8, sucrose 20, sodium chloride 10, ferric citrate 1, bromothymol blue 0.04 gram, thymol blue 0.04 gram, agar 15.0. And this will be dissolved into a 500 ml of distilled water. Then what should we do? We maintain the pH plus minus 7.4. What does this plus minus 7.4 means? That it will be 7.2, 7.4 or 7.6. Okay, maybe 7.3 is also considered and 7.5 is also considered. Now next is Listeria monocyte. Listeria monocyte required media, that is your Palcam agar, polymyxin, acryflavine, lithium, chloride, ceftazidime, scopolamine, mannitol. This is the name of the media, or you can say that full form of the Palcam. So the composition of this Palcam are what? It required peptone, starch, sodium chloride, mannitol, ammonium ferric citrate, scopolamine, dextrose, that is your glucose, lithium chloride, phenol red, and agar. So all these ingredients required per gram per ml. So peptone is required 23 gram, starch required 1 gram, sodium chloride required 5 gram, mannitol required 10 gram, ammonium ferric citrate required 0.500 gram, scopolamine required 0.800 gram, dextrose required 0.500 gram, lithium chloride required 15 gram, phenol red required 0.080 gram, agar required 13 gram, and this all are required for 1000 ml, and the procedure of the maintaining of the pH are same as usual. Now Bacillus cereus. Bacillus cereus required mannitol, egg yolk, polymyxin, agar. Bacillus cereus required the media, and this selective media for Bacillus cereus is what? Mannitol, egg yolk, polymyxin, agar. And the composition of this mannitol, egg yolk, polymyxin, agar are what? Beef extract, peptone, mannitol, NaCl, phenol red, 1%, and this phenol red 1% solution should be dissolved into 95% of ethanol. That means that we weigh phenol red 1 gram and it should be dissolved into a 95% of ethanol. No, sorry. We weigh 1 gram of phenol and dissolve into a 100 ml of distilled water, and here we have to prepare a 95% of ethanol, and for this preparation what we have to do, we do a 95 ml of ethanol and 5 ml of distilled water. Now after that, when these two solutions are prepared, then we take 1 ml phenol solution and it will be dissolved into a 99 ml of 95% of ethanol. Okay, then we required agar and distilled water. The beef extract required 1 gram per liter. Sorry, for 1 gram required for 900 ml of distilled water. Okay, now the next chemical is what? Peptone. Peptone is required 10 gram for 900 ml of distilled water. Then we required mannitol 10 gram, NaCl 10 gram, and phenol red 2.5 gram, agar 15 gram. And this all composition is for what? This is for 900 ml of distilled water. Now next is what? Clostridium perfringens. Clostridia perfringens require CCP agar, that is your chromoselect agar. So we required peptone, sodium chloride, sodium deoxycholate, chromogenic mix, polypropylene glycol, and agar. So peptone is required 8 gram. This composition is again for 100 ml of distilled water or 1 liter of distilled water. Peptone is required 8 gram, sodium chloride required 5 gram, sodium deoxycholate required 1 gram, chromogenic mix required 1.5 gram, polypropylene glycol required 10 gram and 10.5 gram, and agar required 15 gram. And the maintaining of the pH is same as usual. Then Salmonella and Shigella. This Salmonella and Shigella required a SS agar, that is your Salmonella Shigella agar. So the chemical composition of Salmonella Shigella agar are lactose, bile salt number 3, sodium citrate, sodium thiosulfate, beef extract, protease peptone, brilliant green, neutral red, agar, and distilled water. So this composition is for what? This is for 1 liter of distilled water. So lactose is required 10 gram, bile salt number 3 required 8.5 gram, sodium citrate required 8.5 gram, sodium thiosulfate required 8.5 gram, beef extract required 5 gram, protease peptone required 5 gram, brilliant green required 0.00033 gram, neutral red required 0.025 gram, and agar is required 13.5 gram. Again, we maintain the pH and then we do autoclave. Clear? Now we have a last microorganism, that is your Staphylococcus aureus. This Staphylococcus aureus required media, that is your tryptic soy broth. Okay. So the composition of this tryptic soy broth is what? Tryptone, and this tryptone is what? Pancreatic digest of casein. Again, this is for 1000 ml of distilled water. Soytone, that is your pectic digest of the soybean blue. Both sodium chloride and dipotassium phosphate. We require triptone 17 gram, soytone required 3 gram, glucose required 2.5 gram, sodium chloride required 5 gram, and dipotassium phosphate required 2.5 gram. Again, what we do, we dissolve all these ingredients into 500 ml of distilled water, and then we maintain the pH, that is your 7 plus minus 7.4, and after that we added remaining 500 ml of distilled water. Then when do what? We do autoclave. Okay. So thank you so much. This is all about the selective media is required for a particular bacteria. If you have any query, just let me know. Thank you so much.